Okay, chemistry students, this is our last notes for Unit 3. We're practically done with these. So we have already talked about covalent molecules, how to write their formulas, how to write their names, how to draw Lewis diagrams. We've also talked about ionic compounds, how to write their names, write the formulas. We've learned about polyatomic ions, and now it is time to talk finally about transition metals. So let us pop right in. I've got a PowerPoint, so a couple slides to show you, and then we'll go to the notes themselves. All right. So if you remember your periodic table, right, we have predicted all of the charges of the elements except for these transition metals. And I told you that they're not predictable. And that's because they aren't. Transition metals are kind of weird. That's why they're called transition metals. They're always moving from one thing to another, in that there's not really a discernible pattern in their charges. So if you take a look at this chart here, not only is there not a discernible pattern, but they can vary. It has to do with their complicated electron structures. It's a whole thing. But what really matters here is that you will never be expected to memorize these or remember them at all. And in fact, as chemists, we don't really expect ourselves to remember them either. If we have a compound, for example, that has copper in it, how do we know if it's a +1 or a +2? I mean, we know that they're all plus because they're all metals, so they're all cations. But this is just a lot, too much to remember. So we don't. Instead, you are always told what the charges are based on the Roman numerals that are in parentheses. So again, it's not predictable. These are Roman numerals, just in case you don't remember. You really will only have to remember about 1 through 5 at most. Generally speaking, just 1 through 3. So this is 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8, 9, 10. But if you just focus on these, you'll be just fine. So here's some examples. So if you were given a formula of iron chloride, again, what's the charge of iron? I have no idea. Well, we have to say, if I'm going to give you a problem, I will have to tell you. If you write the formula iron chloride, you have to tell me which iron it is, because otherwise I don't know which one it is. In this case, it's iron 2, because it has this Roman numeral 2 after it. So what does that mean? Well, it means that this iron has a +2 charge. So we don't have to worry about, hey, which one of these 2 irons is it? It's the +2 one, not the +3 one. Same thing here with titanium. Titanium, you can see here, has 2 different types, 2 or 4. Oh, well, I guess it's 1, whatever. Doesn't matter. This is a weird titanium, maybe that's super rare or something. Doesn't really matter. This is titanium 1 sulfide. So we know that this titanium has a +1 charge. This is manganese 4, which, yep, can come in either the 2 or the 4 variety. This particular one is 4 because it has the IV after it. So this tells us what the charge of manganese is. It's really that simple. So let's take a look at some examples. You know what? I actually have this on the notes. So let's just do it straight on the notes. That's a little bit more fun, right? Okay. Yeah, I'll just write it out for you. That's kind of nice. Okay, so we are looking here at transition metals. Okay. So, yeah, here's some examples. I can write those down for you again. Iron 2, chloride, maybe silver 1 nitrate. That's definitely something. Oh, I'm sorry. It should be silver, not Ag. Anyway, there's a whole bunch of them. Again, the key here is this tells us that it's Ag +1. This tells us that it's Fe2+. All right, so let's take a look at an example. So if you have to write the formula for iron 3 chloride, you're going to follow the exact same steps for writing formulas in general, just with one small hitch. So we're going to do the same steps. So we've got iron. Iron is Fe. It's right here. Looking up, we don't know what the charge is. Well, luckily enough for us, this I gave it to you right there. So this is going to be Fe3+. Chloride is just chlorine, so that's Cl, that's here, that's a -1 charge. Okay, and now we just need to go through the whole process of neutralizing it so we can write the formula. So it looks like we're going to need 2 more chlorines. That way we have a 3+ here and 3- here. So the formula for iron 3 chloride is going to be FeCl3. Not too bad, right? Okay, how about iron 2 chloride? Well, in this case, it's the same thing to start. We've got iron. If we, again, look at the periodic table, there's really no way of predicting what it is because we didn't write anything at the top because transition metals are weird. However, the 2 means that it's 2+. Chlorine is still -1. It looks like this time it will only take 2 chlorines to neutralize it. So this formula is going to be FeCl2, right? Okay, so pretty straightforward, I hope. One big mistake students make all the time. They will think that this 2 means that there's 2 irons. No, it does not. No, 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 no. Why would I tell you how many irons there are? That's not what chemists do. We wouldn't be that straightforward. Also, we don't have to tell you. Why would we say that? No, we're going to tell you what type of iron it is. Is it the +2 kind or the +3 kind? That's exactly what these mean. It's just telling you the charges. Your periodic table usually tells you everything that you need to know, except for these ones. There's just no way to know. So we're going to tell you when you get to it in that particular problem. All right. So let's see. Let me take a quick look. If you want to practice some of these, you can totally do that. If you look at page 9 of your packets, if you want to practice this, you can do numbers 1 through 9. Sorry, 1 through 7, 8, 1 through 8. So you can see I've already done it, a few of them. Again, these numbers tell you what's up. They forgot to tell you the silver and the zinc. Technically, silver is always +1 and zinc is always +2. So you could memorize it, but you're not going to memorize it. So if you want to pause this video and work on those and then come back, we're going to talk about writing the names. So we'll wait for you. Okay, if you blazed right through the video, that's cool, but if you wanted to go back and practice a bit, that's awesome as well. Let's talk about writing names now. So I'm giving you here 2 examples. Oops, excuse me. Gotta push this back a little bit. 2 examples of formulas, and we need to write the names. So this is an ionic compound. It's pretty easy, right? It's just CuCl. Cu is copper, and Cl is chlorine. Great. So that seems like it's copper chloride, right? One problem. Because copper is a transition metal, we don't know what the charge is. And if you just write the formula, we'll never know what the charge is. I will have no idea, and I won't even have the slightest clue of where to find out. So when you write formulas, you must include the charge written in Roman numerals in parentheses. You have to do it. So we're going to put this little parentheses there, and we're going to put a Roman numeral in. Now the question is, what is the charge of copper? I mean, it doesn't say anywhere. How do we find out? Well, we're going to have to use process of elimination. We're going to have to use some backwards, not process of elimination, it's more like reverse logic, I guess. Reverse math? No, okay. We're going to go backwards. So normally, when we write out formulas, we know the charges and we figure out the ratios. This time, we know the ratio and we're trying to figure out the charges. So it's the opposite method. So here's what I do. I write down the two elements, and I separate them into ions. So copper is definitely positive, but I don't really know what its charge is. It's definitely positive because it's a metal, but I'm not really sure what. Chlorine, I know from the periodic table, is a -1. So if we take a look at this, going back to our box method, we can do this. Draw a little box off to the side here. We've got our minus. We've got, sorry, juggling a lot of pens. We've got our plus, okay? We know that we have one minus. According to this formula tells us that 1 copper and 1 chlorine, that ratio is neutral. So if we have 1 minus here, we also must have a total of 1 plus. So we only have 1 copper. So that copper must be 1 plus in order for this to make sense. So in order for this formula to work, and it does work, it is correct. I wouldn't have written it that way if it were wrong. You have to have, the copper has to be +1, the chloride is -1, it's a 1-to-1 ratio, and it's neutral. So what we're gonna do here is we're just gonna put a Roman numeral 1. So it is copper 1 chloride. Cool, right? Yeah, it's a little funky, but you'll get used to it. It's not too bad. All right, let's try another one. Let's do this. So Zn is zinc. Uh-oh, it's another transition metal. We don't know what its charge is. I don't know. Let's figure it out. We're not going to give up. We got this. Okay, so Zn, we know that it's positive at the very least. But is it 1 plus or 2 plus or 3 plus or 4 plus? I mean, who the heck knows? We'll find out. All right. We also have phosphate. So phosphate is a polyatomic ion. It's on the back of our sheet. Oh, I'm sorry. Yeah, that's fine. Okay. So let me just write this off here. So we know, sorry, this is zinc something phosphate. So PO4 is phosphate. We can find this on our back of our sheet. It's a little hard to read, but it's right there. Phosphate, you'll see, is a 3- charge because it's in the 3- charge category. Okay. So what is the charge of the zinc? Well, let's work backwards. Here's what we know. We know that zinc phosphate, this formula, this ratio here is neutral. We know that there are 3 zincs because of this 3 here. We don't know what their charge is, but it's got to be positive. And we know that there are 2 phosphates here because there's a 2 there. Remember that you have to do those parentheses around the phosphate. Very, very important for polyatomic ions. Okay, so let's go back to our little box method. I think this is a great idea for this problem. So, positives, negatives. Okay, looking at this, it looks like because we have 2 phosphates and they're each a -3, that is going to be a total of -6. So -3, -6. 3 plus 3 is 6. So there's a total -3 charge. Therefore, there has to be a total of +6. It's the only way that this could possibly work, right? So what would the charge of zinc be? Well, if there are 3 zincs, each zinc would have to be a +2 charge. Let's see if that works. Okay. So if each zinc is a +2 charge, it would be 2, 4, 6 positive. That works. The phosphates, 3, 6 negative. Totally works. So we went backwards. We took the formula to figure out what that charge is. So zinc must be +2. So we're going to put a 2 in the parentheses right there. Okay. All right. So that is our essentially our method for this, and that's the last little bits of notes. In the grand scheme of things, this is good to know, but it's not as crucial. On the test, there definitely will be a couple problems that will show up like this, but you can still do okay if you're a little confused still. But definitely work on it. It's a good thing to know. It really proves that you understand what you're talking about and that you really understand what formulas are and what names of compounds are. Overall, ionic formulas, this stuff is the most important thing. So that's all. What we'll do for the rest of this week, oh yeah, I'll show you this, sorry. You are now able to do all of page 9 And in fact, you can do the entire rest of this packet now, all of it. All of this is just practice, and some of it is just ionic formulas. So this is some ionic formula practice and more ionic formula practice, names and formulas. Ionic, there's polyatomic, there's transition metals, there's just simple binary compounds. It's all mixed in. Starting on page 14, it's a mix of ionic and covalent. So that's page 14, it's got ionic and covalent. Same thing with 15 and 16 and 17. And then 18 is your test review. So that's what we're working on for the rest of this time that we have for this unit. So yeah, it's just a matter of practicing this until it makes sense. So again, if you ever need my help, please, please, please ask. You can ask after class, you can email me, whatever you need, and we'll make sure that you understand this really well. Be excellent to each other, and I guess I'll catch you at unit 4. Crazy.